Okay, so what we're looking at here is kind of a tree diagram, right? And a lot of times your book, instead of using P1, P2, P whatever, how they describe it is like A and not A, and then B given A, not B given A has occurred, and so on and so forth. So that, oh, sorry, this would be not A. Come on, there we go. So therefore, here we'd have B given not A, and not B given not A. So that's the general structure, right? We're saying either A happens, or A does not happen. Then, given that information, now that we know A has happened, either B can happen or B cannot. It's cannot happen, and so on and so forth. So let's kind of put this together. So what they're saying here is, okay, we know this branch going towards A, and so they're using A and B and C, so but it's still the same idea. Either A can happen or B can happen. And what they're saying is probability 1 is A. So we know the likelihood of this happening is 0.2, or aka 20%. Now, if you know outcome A happens 20% of the time, then what can we figure out about going down this other path? Because either one has to happen or the other one has to happen. So I know who I'm talking to, and I think you're already saying I know the answer. So if this happens 20% of the time, then we know that this happens 80% of the time, because it has to be the rest, and we know it has to add to 100%. So there's our logic. So now what we're saying here is the probability of A and C occurring is the end of the branch. So what we need to do to be able to figure this out, we need to figure out the in-between steps. So, and what they're telling us here is this is probability 2, which is 60%. Okay. And note, I think they're writing as decimals. So instead of writing percentages, you'd write it as decimals. Same idea though. Okay. So 60%, 0.6. So if this branch, knowing that A has occurred, this happens 60% of the time, then how often is this? How often are we going to go towards C? Well, it's got to be the rest of the 100%. That's 40% of the time. So is that okay? Hope that's okay. So now there should have been a formula on conditional probabilities that you learned that said something like this: the probability of A times the probability of B given A is equal to the probability of A intersect B, or something like, giving whatever letters. But the idea is, what we're saying here is just I'll go to this matches this. So the probability of A would be this branch right here, just going through A. Then the probability of B given A is that branch there, and that is equal to the probability of A and B occurring. So what we're saying is, what is the likelihood of going down that entire branch, going from the start and then going down this path? And what we're seeing from here is the probability of going from the start to A, then from A to C. We have a 20% chance of going through this, then a 40% chance of going through that. So 20 times 40 would make, try again, 2 times 4, right? 2 times 4 makes 8, but then it's 2 decimal places, so it'd be 0.08. So we have a 0.08% chance, sorry, not percent chance, we have an 8% chance, but a 0.08 as a decimal form, of that occurring. And hopefully, yay, I got it right. Okay, so that's the idea here. What we're doing is kind of working from this formula and understanding what this formula is saying is the probability of A and B occurring is equal to the probability of A occurring times the probability of B occurring when you know A has already happened. That's the idea of conditional probabilities. I hope that helps. I hope that makes sense. So now you can kind of, I only did that first branch, so you can kind of rinse and repeat and see if it's sticking. Okay, best of luck. Let me know if you need more.